Let's talk about transforming functions. If we take our basic function and we move it around the coordinate plane, mathematically speaking, we call that transforming it in the coordinate plane. We can apply several rules to that. We talked about vertically moving our functions, shifting them up and down. We talked about horizontally moving them, shifting them left and right. Two things that we have not yet talked about are vertically stretching them and vertically shrinking them. Note, you will learn about that in pre-calculus. That A value in front, we briefly talked about it with quadratics, parabolas. Our parabola can be a wide, stretched parabola. It can be a narrow, thin one. And that A value in front of x squared determines that. You're going to learn more about that next year. We did talk about what happens if A is less than 0. That is a reflection about the x-axis. That, we talked about when the parabola opens up versus when the parabola opens down. HK, those were the variables that allowed us to shift our parent functions around the coordinate plane. So I put a little box there to remind you of what those shifts look like in terms of up, down, and left, right. So we will utilize that as we review graphing our parent functions. So take the basic parent function and maybe do a quick sketch in it. You could even do it in a different color. The square root of x plus 2, so if we look in our box, that is where the plus 2 is in the function. So that means it's going to be either horizontally shifting right or shifting left, okay? Because it is plus 2, this is really the square root of x minus a negative 2. And so we are shifting 2 units to the left. And so we take that function over 2 units. That means the point 4, 2 would shift over to 2, 2. That means the point 9, 3 would shift over to 6, 3. And my function looks like that. Okay. HK is now at negative 2, comma 0. We did not do any vertical shifting there. Okay. If we were to talk about domain and range, just to review those concepts from earlier, the domain now has gone from 0 to infinity to negative 2 to infinity. The range is your y values. And if you recall, we talked about them being the lowest y value to the highest y value. Well, the lowest y value pictured in this graph is 0 to infinity. All right, let's look at the next one, which is the cube root graph. And again, you can pick a different color and you can plot your cube root. So that we can actually see the transformation. We have x plus 2, which we explored in the previous one. We know this is a shift left 2, that plus 3, that is a shift up 3. So we're going left 2, up 3. So that means our HK is negative 2, 3. So that means that 0, 0 is going left 2, up 1, 2, 3. Okay, so that 1, 1 is going left 2, up 3. And then that means this one is going left 2, up 3. This one is going left 2, up 3. And this one is going left 2, up 3. And so then you want to be able to take that and draw your cube root. And so it's helpful to have some target points on your basic parent function as you shift them according to the transformation rules. Domain, we didn't talk about the domain or range for the cube root. Negative infinity, positive infinity, negative infinity, positive infinity. We don't have any restrictions on the domain. We can take the square root of positives, or excuse me, the cube root of positives, negatives, and 0. Okay, third example, cube root of x, subtract 4. So this is a shift. You're going to take your cube root function and you're shifting it down 4. And so your HK is going 0, negative 4. So again, you can sketch your function. So 0, 0, 1, 1, negative 1, negative 1, 8, 2, negative 8, negative 2. Now think about that. The cube root of 8 is 2. The cube root of negative 8, negative 2. So let's take a look at our parent function right there. And now we're going to shift it down 4. So everything is going to shift 4 units down. So 1, 2, 3, 4 down. 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 And now we have a nice picture. You can always check these in Desmos, but down the road you will be held accountable to the parent functions without the use of digital technology. Okay, let's do one more. We've got this negative out front here, and that means something. So if we go back up here, we remember that when a is less than 0, that is reflecting us about the x-axis. So if we have a negative in front of our function, this is a reflection. So we're reflecting over the x-axis, and then we are having a horizontal shift left 2. All right, so that means my HK is going to still be at negative 2, 0, right? Just like it was in the very first example, only instead of your square root starting at negative 2, 0 and going up to the right, it is now going to be reflected and start at negative 2, 0 and go down and to the right. All right, so what does that parent function look like? Again, 0, 0, 4, 2, 9, 3. Those are my standard points. Okay, and now I'm shifting to the left 2, right? And so what's going to happen with that 4, 2? Well, even if you aren't sure, go ahead and plug 4 in. 4 plus, and instead of, I guess we could plug in 4. 4 plus 2 is 6. So you would be taking the square root of 6, but it would be negative, so it would end up having to be down below the y or x-axis. But instead, let's do like 2. Let's plug in 2. So 2 plus 2, so why would I say 2? Like, where did I pull that out of that? Plug 2 in. Because if I plug in 2, 2 plus 2 is 4. The square root of 4 is 2. Take the opposite, negative 2. So 2, negative 2. All right? Then I'm going to plug in 7. Why 7? Because if I plug in 7, I'm taking the square root of a perfect square. 7 plus 2 is 9. The square root of 9 is negative 3. So 7 is negative 3. And that's your answer. Let's do domain and range. So domain, again, not changing, negative 2 to infinity, but range. Wow. So lowest y to highest y. So we're revisiting range. The lowest y is negative infinity because that graph keeps on going down. The highest y is 0. So we're revisiting domain and range and our parent functions square root and cube root because we just finished our topic on doing nth roots.